Do you guys remember when we talked about end behavior the first time around?
Yes.
Do you remember what day it was?
No.
How can you forget September 20th?
It's like,
How can you forget? It was such a momentous day.
yes.
So take a look. When we were talking about end behavior a long, long time ago, 3 months ago, almost to the day 3 months ago, 4 months ago.
What?
4 months ago. End behavior describes the value of the function at the positive and negative extremes. Right? So that means you look at the arrows, which way are the arrows going? It was pretty self-explanatory. Hold on, I'm talking. It was pretty self-explanatory before, right? Either they're going up, one's going up, one's going down, one's going down, one's going up, or they're both going down, right? And we use this phrasing as x increases, y increases. As x decreases, y decreases. Give me a thumbs up if that sounds at least slightly familiar. Okay. I see you're all enjoying your rulers. It's okay. I know. It's the end of the day. It was a long weekend. As you see, everyone's just over here. Just playing with the rulers. All right? Here's why we need the rulers, okay? You're going to find as close to perfectly halfway through your paper as possible. So mine is 7 1/4. I'm going to go 3.75, something like that. Right there. Okay, you're going to split your notes paper directly in half. Like so.
Like halfway?
Yeah. 9 1/4, 4 3/4.
Halfway as
Should have 4 quadrants. No. We did graphs.
like I didn't write them.
Oh yeah, we were given a graph.
Like I haven't drew like a graph since.
Oh.
Excellent use of the ruler.
Oh. Like I promise you I use it. I promise you I use it. Even though I drew this coordinate. Walk on the crowd that little. Bro, I forgot about that. I redrew it.
Good.
I just don't know how to like my rule, I don't know how I'm supposed to use a ruler to make my stuff straight and still.
Okay, as long as you have 4 sections, you're fine. Give me a thumbs up if you got all 4 sections now. Your little quadrants. Okay, we're not making a graph. We are organizing our thoughts because this can tend to be a little confusing because it is confusing. It's not that confusing, but it kind of is. So, let's take a look back real quick. Okay. If I have a graph that looks like this, an exponential graph that looks like this one here, right? What's happening to my right arrow? It's going up, right? How far is it going to go up? Forever. So what number will be used to represent forever in this case? Infinity. Good. What's happening to my left arrow? It's getting closer and closer to being straight. Is it ever going to be perfectly flat and straight? No. What is it getting very, very close to, though? Zero, right? It'll never, ever actually cross 0, but it'll forever get closer and closer and closer, right? Because every decimal you can split into a decimal, which you can split and split and split, right? So this, even though it approaches that 0, it's never going to reach there, right? So my right side is going to infinity. My left side is going to 0. This is the kind of verbiage that we're going to be using as opposed to Oh, it's increasing. Oh, it's decreasing. We're approaching certain areas. Okay. The reason why I'm breaking this down into 4 is because our exponential functions can be one of 4 shapes. Okay. This first shape we're going to call option A. Okay. In this first option, right? This is like your standard exponential function. We have a positive A value with a B value greater than 1. We have a positive A value with a B value greater than 1. For example, f of x is equal to 2 times the quantity of 2 to the power of x. Remember, A is what's in front, B is what's underneath as the base of my exponent. So here I have a positive A value with a B value greater than 1. Give me a thumbs up if you see that so far. Okay. Good. Let's see what that looks like. I'm going to go back to my little, well, might as well do it on this. So we can see it on the same screen. Okay? Let's say I've got f of x is equal to 2 times 2 to the power of x. Okay, what's that look like? Well, it looks like that. Everybody see that? Where's my right arrow going? It's going up, up, up to what? Infinity. Where's my left arrow going?
0.
Towards 0, right? So here's how we're going to explain this in terms of end behavior, right? We're going to say, as x approaches positive infinity, y is going to approach something. And as x approaches negative infinity, y is going to approach something else. Where on the graph am I looking if I'm trying to find x going towards positive infinity? What does that even mean? Ava? Oh, I thought you had your hand up. Okay. Think about it for a second. What might we mean by x approaching positive infinity? Just think about it. See if you can talk with someone next to you. What do you think these two things mean as x approaches positive infinity and as x approaches negative infinity? See if you can come up with something. To like 30 seconds. All right. What did you guys come up with? Any ideas? What does it mean when we say x approaching positive infinity, x approaching negative infinity? I see you, Alex. What else did we come up with? Nobody came up with anything. Aaron. What's that? This one right here? Yeah, there is a negative infinity. Where would negative infinity be in relation to x?
Down.
Down? Is that my x-axis? To the left. So where might positive infinity be? To the right. Is that what you were going to say, Alex? What were you going to say?
I was going to say the positive infinity is the left. It's the right on the number line.
Yep.
And the negative is the left on the number.
Exactly. So if we start in the center, right? If I want to go to positive infinity, I'm going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to go to the right forever and ever and ever. You guys see that? Does that make sense? If I'm going to negative infinity, I'll start with negative 1, negative 2, negative 3, and I'll go all the way to the left forever. So if I'm thinking as this function, this curved line here, as it's moving to the right, where is my arrow going? Up. Towards what again? Positive infinity. So as x approaches positive infinity, y also approaches positive infinity. What this statement here means is as I move to the right on my x-axis, my function is going up. That's all that means. So if I want to find what's happening to my y when x approaches negative infinity, I'm going to look to the left, to the left, to the left. What's happening to my left arrow on this function? What is it approaching? Infinity? It's approaching 0, like we said. It's getting closer and closer and closer to 0, but it'll never quite reach it. So as x approaches negative infinity, now y is approaching 0. This is my end behavior for the first type of exponential function. We have a function with a positive a value and a b value greater than 1. Okay? I could have had a function that was 4 times 3 to the power of x. Whoa. What did I do? Oh, okay, it graphed it as a system. My bad. Maybe it didn't. Stop doing this to me.
It's time for a new calculator.
Oh, it was just filling in the.
I think your calculator is broken.
Whatever. Hold on. 4 times 3 to the power. Okay, there we go. Right? See how to the right we're going up towards infinity, to the left we're going down towards 0. It's always going to look like that, okay? So what is this shape? It looks like this. Make sure you draw that little curve right there in the corner. Any questions on that first one? We got to get going because we got 3 more. I'll be talking for way too long. Next one is B. Outcome B. We're still going to have a positive a here for this outcome. But now my b value is going to be greater than 0 and less than 1. As we saw in the warm-up, when I have a b value that's less than 0, when I have a negative b value, negative common ratio, I get that weird oscillating function where my points are going back and forth. So I'm never going to have a b that's negative. But if I have a b that's in between 1 and 0, what's a potential b value that would fit that? Just shout it out. What is in between 0 and 1? 0.5. 0.76, sure. 0.333, right? 1/3. What about 3 over 2? No. 3 over 2 is 1.5. That's greater than 1. So an example of this type of function would be something like this. F of x is equal to 2 times the quantity 0.5 to the power of x. Let's figure out what our end behavior is going to be for this one. I'm going to go to my little graph here and try not to mess it up. 2 times 0.5 to the power of x. Let's see. Ooh. What happened to our function? It went backwards, right? What's a math term for something going backwards like that?
And
Flip, yeah. What's the technical name for a flip?
mirror.
Mirror, even more technical than that? Reflection, that's right. We reflected across the y-axis, okay? Now, as x approaches positive infinity, again, I'm looking to the right, to the right, to the right. What's happening to my function now? Where is it approaching? 0. As my x-axis goes to the right, my function is approaching 0. But as my x value goes to the left, my x-axis goes to the left, what's happening to my function now?
It goes to the positive.
It's going up to positive infinity. So the second type of function, or b function, is always going to look like this.
Okay.
Just like that. You see that? Just like that. Okay? So all we did was we flipped what happens to y when x is approaching positive and negative infinity. If you're trying to visualize that, right, that's exactly what a reflection across the y-axis would do. It would flip what my end behavior is. All right? Questions on that so far? Okay, let's do C. Function numbered or lettered C. I'm going to leave some space because I'm going to add some stuff in there. C. So C now, we're going to have a negative A value. Remember, A is kind of like our y-intercept. So these lines are going to be below the x-axis. We have a negative A and a B value greater than 1. For example, f of x is equal to negative 2 times the quantity of 2 to the power of x. Now this is what we saw on this number 2 in our warm-up, right? We had the negative 1 in front and then my base to the power of x. Let's figure out what our end behavior is going to be here. As x approaches positive infinity, y approaches something. As x approaches negative infinity, y approaches something. Let's go back over here. See if I do f of x is equal to negative 2 times the quantity of 2 to the power of x. Ooh. What happened to my function now? It went down. It's still reflected, right? But where did it reflect across this time?
The x-axis.
The x-axis, right? We went from up here, flipped it to down there. So let's see. As x approaches positive infinity, as I go to the right, to the right, to the right, what happens to my function? Where's it going? Negative infinity. Beautiful. I love all of you that said that. You're absolutely right. As we go to the left, to the left, to the left, what happens to my function? Where is it approaching now? 0. Right? We're getting all right up close to that x-axis. That's 0. Okay? And this third function looks like this. We can hopefully assume what the last one's going to look like based on our little drawing here. It is what you think it is. Sound good on C? I know we're moving kind of quickly through this, but now D. Our little option D here. We still have a negative A in option D. What do you think's going on with my B value, though? Yeah, Alex?
It's greater than 0 but less than 1.
That's right. So this is kind of like a double negative, right? We have a negative sign in front and a decimal or a fraction in the middle. Something like this. f of x equals negative 2 times the quantity 0.5 to the power of x. If I go to my calculator, plug this exact function in, and hit graph, we should see now that we reflected our c function across the y-axis to give me a nice completed little image of a function that looks like that. 4 types of exponential functions, a, b, c, d. Give me a thumbs up if you see that. Okay. Now, what's my end behavior here? As I go to the right, to the right, to the right on my x-axis, what's happening to my function? What's it approaching? 0. And as I go to the left, to the left, to the left, what's it approaching? Negative infinity. So with the way that we've organized this information, it can be a lot, right? If we look at it, it's kind of hard to tell what's different about it. Every little box looks the same. But the more you look at it and the more you start to compare these different types of functions, the more connections you're going to start to make, right? Like if you'll notice, only a negative a can give me a y approaching negative infinity, right? So when I see that negative sign in front of my function, I should know that my end behavior is going to have a negative infinity in there somewhere, okay? If my b value is greater than 1, we're going to add this in here. If my b value is greater than 1, that means I have a growth function. Okay, that's my a and my c on the left side. Growth just means I'm approaching an infinity. Could be positive, could be negative, right? So this green arrow's approaching positive infinity. This blue arrow's approaching negative infinity. But what are this red and this blue line over here? What are they both approaching going to the right? 0. See how this one's dropping down to 0? This one's coming up to 0. If I'm approaching 0, I'm not growing at all. I'm decaying. Question, Alex?
No.
Okay. Okay. Another thing to notice, hopefully, is if my a value is positive, right? A is like my y-intercept. So if I have a positive y-intercept, then my function is going to be in above the x-axis. So q1 slash q2. If I have a negative y-intercept, my function is going to be below the x-axis, which is going to land me in quadrants 3 and quadrants 4. So up on the top, A and B, they're only going to be present in quadrants 1 and 2. Down below, C and D, they're only going to be present in quadrants 3 and quadrants 4. Which is, again, why we did, it kind of is like a graph. These two types of functions are going to be above the x. These two type of functions are going to be below, okay? And if I take all 4 of those functions and plug them into the same graph, here's what that looks like. Do I still have it up? Yes, I do. Boom. There they all are.
Oh, wow, that's a cool shape.
Right? That's exactly what we just drew. So it's the same line just being rotated, or sorry, being reflected, right? If I take this original red line and reflect it across the y, I get the blue. Then I reflect it across the x, I get the purple. Then I reflect it across the y, I get the green. Reflect it across the x again, and I get the red. Right? Kind of cool. So that's going to be what we're adding in today to our work. Again, I know that looks like a lot, but this is one of those things where the more you look at it, the more sense it really does make. Some of you just take your notes and you're like, oh, I got it, I'm good. I promise you, this specific lesson, going home today or tomorrow or whenever and reading through all this again is going to start making connections in your brain on end behavior and all that kind of stuff. Because once it's all jumbled up, it might not be as organized in our heads.